All right, so this is 4. It's the partial fraction decomposition. First step for all partial fraction decomposition is look at the denominator and see if you can factor it. So the x is already taken out of this, but you can actually factor this a step further and do x minus 1 and x minus 1, which means it'd be x minus 1 squared. So this is a repeated factor 1. It's repeated factor because I have something that's raised to an exponent, right? So something squared, something to the third, those would be repeated factors. So I start these the same way, but then they are very different moving forward. I do a over the first term, b over the next one, and I got to build up to the exponent. So if it's x minus 1 squared, I have to do x minus 1, and then I have to do x minus 1 squared. If it was x minus 1 to the third, I'd have to do x minus 1 to the first, x minus 1 to the second, x minus 1 to the third. Then I'm going to multiply each of these by what's missing from the denominator. So if I compare each of these denominators to the factored form, that's what I'm seeing what's missing. So x on the bottom would get x minus 1 squared. X minus 1 on the bottom is going to get x and then x minus 1. And x minus 1 squared on the bottom is just x. So I'm going to rewrite just the numerators out because that's what I'm going to focus on moving forward. 2x squared plus 3x minus 1 equals a times x minus 1 squared plus bx times x minus 1 plus cx. Yep.
When you do the denominator, why don't you do x and x squared?
Because it's not x squared. X is just to the first power. It's only if they're raised to a power bigger than 1 that you have to build up. Yep. Correct. Yeah, so if it was like x plus 1, and x minus 1, the first step would still be the same, like, but I don't have to build up.
Okay.
Yeah.
Which one would it, like, what would the denominator be if it was like x squared?
So it would be x squared, you mean? Like x squared times something? It'd be x, and then x squared, and then whatever the other thing is. Yep. All right, so I'm going to expand and FOIL the x minus 1. I know this is x squared minus 2x plus 1 because that was over here, right? We already did that. And then I'm going to distribute the a, the bx, all of it. So I get 2x squared plus 3x minus 1 equals, the a's going to all of this. A times x squared is ax squared minus 2ax plus a. Order there like the 2ax could be 2xa. That order doesn't matter. Then I'm going to do the b, x times both of these. So bx squared minus bx. And then I'm going to do the c. So normally that first step is different, right? When it's not a repeated factor, we would take and just plug in one at a time the numbers that are going to cancel out these constants. But because it's a repeated factor, you'd never be able to cancel out the x minus 1. It would cancel both times every time. So this is why we have to do this a little differently. So once we expand out that first line, then what we want to do is coefficient grouping. So I'm going to go and find all the x squareds. So I've got a 2x squared, a ax squared, and a bx squared. And I'm going to set those all equal to each other. Let me do it in the same color. 2x squared equals ax squared plus bx squared. Then I do that with x to the first. So 3x to the first would be negative 2ax and negative bx and cx. So 3x would equal negative 2ax plus, minus bx plus cx. And then the last one is the constant. Negative 1 equals, and the only one that's constant on the other side is a. So negative 1 equals a. Yep.
So if it weren't have been building up, you would have just started plugging in your x.
Right.
After you distributed the a's.
You don't even have to distribute. You don't want to distribute because it's going to cancel them out. It's going to make it easier to keep them not distributed. Yeah.
That's if it doesn't build up.
Correct. So if there's not a repeated factor. So now I can simplify from the first one, I can cancel out all the x squareds because I could divide, each term has the x squared. If you've done it right, this is how it will always work. And I get 2 equals a plus b. And then I go to the one that all has the x to the first. So I want to divide them all by x. And I get 3 equals negative 2a minus b plus c. And then the last one is already simplified. It's got a equals negative 1. So I actually have a triangle system here. If you wanted to write it out, you could, but you don't need to. I have one that's got 3 variables. I've got one that has 2 variables, and then I have one that only has 1. So I already know a is negative 1. I'm going to take that and plug it into the one that has 2 variables there. So 2 equals negative 1 plus b, and b would equal 3. And now I'm going to take the a and the b and plug it into the last one there. 3 equals negative 2 times negative 1 minus 3 plus c. 3 equals 2 minus 3 plus c. 3 equals negative 1 plus c, and c would equal 4. Now I've got all 3 numerators. So the a goes over the x. It would be negative 1 over x. The b goes over the x minus 1, so plus 3 over x minus 1. And the c goes over the x minus 1 squared. So plus 4 over x minus 1 squared. Yep. Sure. That's a squared. If you had the extra time, and that's a big if because there's a lot of stuff in this section, like I don't think you're going to have the extra time if you take into consideration the 3 variables and the word problems and all that stuff. But if you did have extra time, you could expand and FOIL that out.
Can you go back to when you solve for C?
The purple one in the middle. All right, so we're going to work through the quiz review. Again, these are the ones that's labeled notes, and then there's or it says blank. And then there's the one that's the homework questions. So logistics on your quiz, which is tomorrow, obviously it covers 7-1, 7-2, 7-3. You can use scientific calculators only. If you do not have a scientific calculator, you don't have access to a scientific calculator, I'll let you use the lockdown browser one. Okay, it's not as user-friendly as like a handheld scientific one, so I would recommend getting a handheld if you don't already have it, or borrow one. Yeah.
So like a TI-84, that's a graphing calculator. We wouldn't be able to use it.
Correct. If you can graph on it, you cannot use it. Right. And I'll give it to you. You can have it for the whole time. So you can use it to do your simple math, but really the idea behind it is to help you with all like the word problems that have the decimals and that kind of stuff. So from 7-1, you did substitution and graphing. Substitution and elimination, you're going to be able to bounce back and forth between. It might suggest it, but you don't. I mean, it's just going to say solve the system. But when it says solve it using graphing, you're going to have to solve it using graphing. So we're going to practice both in the beginning here. But if it doesn't say, if it just says solve, you get to choose. There is going to be, however, at least one that has where you have to graph it. So we'll do both. So for the first example, it says 2x plus 2y equals 20, and then x equals 2y plus 1. If this was set up and it just said solve, you had your choices between elimination and substitution. It's already set up for substitution, so I would say it's easier to pick it, but you would get to choose. Yep. So I would plug that in. I'm going to get 2 times 2y plus 1 plus 2y equals 20. I get 4y plus 2 plus 2y equals 20. 6y would equal 18. Y would equal 3. And then I take and plug that back in. I can plug it back into either of them since this one's already solved for x. I would say it's easier. 2 times 3 plus 1. And I get 6 plus 1, which is 7. So 7-3 is the solution to this. And I just found it using substitution. But we're also going to practice the graphing.
Would there be a part on the quiz where you suggest this graph?
Yeah. All right, so these I'm going to solve for y. 2x plus 2y equals 20. 2y equals negative 2x plus 20. Y equals negative x plus 10. That's one. The other, I would have to solve x equals 2y plus 1. I can just subtract the 1 and then divide by 2. So y would equal 1/2 x minus 1/2. All right, so I'm going to graph the first one, y equals negative x plus 10. I would start at positive 10, and then my slope being negative 1 means down 1 and left 1.
Wait, I thought that the line for this one was 3. Oh. Wait, what?
I'm graphing y equals negative x plus 10.
Oh, right, it's 2 systems.
Right. Then I'm going to graph the pink one. Y equals 1/2 x minus 1/2. So I'm starting at negative 1/2. I'm going up 1 and over 2. Up 1 and over 2. I haven't hit my other line yet, so I'm going to keep going. And that's when I hit it. And the coordinate point here is 7, 3. And then a big if, but if you had time, you could check it using another method. I don't care if you check it using another method, but you have to, I mean, your graph is going to be part of your answer. You're going to have to find that graph. And the graph has to be consistent with what your answer is. All right, so then we're going to practice because this one's nonlinear, right? So this has a squared in it. If I use substitution, I can solve the top one for y or the bottom one. It doesn't matter which one you solve. I could do negative y equals negative 2x plus 3, and y would equal 2x minus 3. This is going to help me too because I'm going to have to put it into that for graphing it later. Then I'm going to take that and I'm going to plug it in here. X squared minus 2x. Now this minus goes to both, so 2x minus 3 equals 11. The negative goes to both, so x squared minus 2x plus 3 equals 11. As soon as you see the squared and the non-squared, it should be your hint that you're going to have to factor. So I'm going to get everything to one side. And then factor. X minus 4 and x plus 2. Split and solve, and I get x equals 4 and x equals negative 2. So I'm going to have two solutions here. One in which the x is 4 and one in which the x is negative 2. I'm going to take those each and plug them back in. I'm going to plug it back into the one I already solved for y. So y equals 2 times 4 minus 3, which is 5. Sure, it's just the other one's already solved for y, so it's one less step. Y equals 2 times negative 2 minus 3, negative 4 minus 3, which is negative 7. Now let's pretend it had said solve using graphing from the beginning. I already had the first one solved, but this one I also have to get into standard form. Because it's got an x squared, what's going to happen with this graph? It's a parabola. Negative x squared plus 11. So y equals x squared minus 11. So I'm graphing those two. Y equals 2x minus 3. You could either go up 2 and to the right 1, or down 2 and to the left 1. And then I'm going to graph y equals x squared minus 11. Now the only exact point, I'm going to graph it in teal so you can see a little better. The only exact point you have from that is negative 11, which is like all the way down here. And I know based on transformations that it shifted down 11, but it opens upward, right? So you can kind of approximate what it looks like. But in order to find exact crossing points, you're going to have to plug in points. I know because there's no stretch or shrink that it's up 1 and to the right 1, so the first 2 points are there. So I don't want to plug in those points. But let's say I go back, so this is -1. I go back to -2. I would take and plug in -2. So y equals -2 squared minus 11, and that's 4 minus 11, which is -7. So I'd go -2, 1, 2, 3, 4, 5, 6, 7, -7. Wait, it should have crossed there. Just kidding. This is -1. This is -2. 1, 2, 3, 4, 5, 6, 7. There we go. I went to -1 first. So now I know that is one of my points of intersection.
Why couldn't you have plugged in like -1?
I could, it's just not going to line up. So you could plug in -1, but if you think about every parabola, unless there's a stretch or a shrink, from your vertex, you always go up 1 and over 1. So I knew that coordinate point was here, like here, and that was not on my line. So I just didn't want to waste the time plugging it in. You could, it just wouldn't overlap.
You're allowed to reflect, right?
Yeah, so now I know I went up 1, 2, 3, 4, and over 2. I can go up 1, 2, 3, 4, and over 2. Now that point is not in line with anything that's on my my line. So I know I'm going to go up again. So because this is 1, this is 2, maybe plug in 3. So y equals 3 squared minus 11. 9 minus 11 is -2. I want to see if 3, -2 is a coordinate point on my line. 1, 2, 3, -2, and it's not. So then I'm going to go to the next one. I'm going to plug in 4. Y equals 4 squared minus 11. 16 minus 11, which is 5. So 4, 1, 2, 3, 4, 5 is a point that's on both my curve and my line. So that's the other point of intersection, which matches what we found from substitution. You just probably won't have time to do both methods. Unless you're a mess with graphing. If you're a mess with graphing, then do it a different method. Just confirm it with the graph. Your question has to have a graph.
So instead of picking random points, can we put in what we got and see if it?
If you've already done a substitution, you won't have to do it both ways.
Oh.
Yeah. So, I mean, you might get lucky and get 2 lines like the first one. It's not so bad, right? Or you get a parabola and a line, but maybe it's a little bit more obvious. Yeah.
So if it says do by graph, we could do it by substitution as long as you show the word. first.
You just also have to graph it.
Yeah.
Yeah, like I don't know what order you do that in, right?
Yeah.
Yeah. It's just a waste of extra time. If it's easy, something is easy, you shouldn't have to do it twice.
Wait, so for graphing, you just make it to y equals mx and then plug in points to see which one.
You don't even, with the 2 lines, you didn't even have to plug in points. You just graph the 2 lines and see where it crosses. Yeah. You only do that like if it's that parabola that was way off. It wasn't right on top of it, so I had to plug in extra points. Yeah. All right, there were 2 special cases when you're dealing with substitution and graphing. The special case for substitution is if the variables, both variables, cancel out and false statement is left. Then it's no solution. If both variables cancel out and a true statement is left, like 0 equals 0, then it's all real numbers. And you could do ARN. You could do the little fancy R with a double line. You could write the words all real numbers. I don't care how you communicate that to me. Infinitely as many. When you're graphing, the 2 special cases come from parallel and intersecting lines. So parallel lines would be no solution because they're never going to cross. Overlapping lines, so the same, you end up with the same equation, would be all real numbers because every single answer would overlap. All All right, then came 7-2, which was elimination. And again, with these, it will just say solve, and you can kind of bounce back and forth between elimination and substitution. It's up to you. The only one that's going to force it is going to be the graphing. So with elimination, and I wrote it over here, but it's the same cases, same special cases as substitution. So if it all cancels and it's a false statement, it's no solution. If it all cancels and it's a true statement, it's all real numbers. So I'm going to practice these. I feel like we're a little bit better than these, so I'm going to go a little bit faster, but let me know if I need to slow down. If you're looking at the first one, and it would just say solve, the X's and the Y's are already lined up. If you wanted to solve this using substitution, you could, but because the X's and the Y's are already lined up, I probably would have used elimination. If I go to the X's, I have to multiply both of them. I don't want to have to do that if I can avoid it. I'm just going to multiply the top times 5, and then it will cancel out the Y's. So I get 20x.
During the quiz.
All right, from here, you're going to add these two so that I get 23x. These cancel, equals 69. Divide both sides by 23, and x is 3. Then I'm going to take that, I'm going to plug it back in, and it doesn't matter where I plug it back in. If you want to pick the first one, you can. 4 times 3 minus y equals 10. 12 minus y equals 10. Negative y equals negative 2, and y equals 2. Every answer to your system needs to be in coordinate point form, and be very careful. Make sure it's x, y. People tend to switch those sometimes. You don't want to make a mistake like that. And you're not giving me x equals and then y equals. It needs to go in coordinate point form. Easy stuff, right? Just don't make a silly mistake with signs. Like, people do some weird stuff. Okay, this is now elimination, but you've got quadratic, which means I'm still going to have 2 answers, right? So for me, I would say just change the signs on the y. So I hate an x squared that's negative when you go to factor it. So I'm going to make the top one by negative 1. Negative 2x plus y equals negative 3. And I get x squared minus 2x. Those don't get combined into 1. The y's cancel, equals 8. We did this one using graphing, so we already know the answer. X squared minus 2x minus 8 equals 0. Factors of negative 8 that sum to negative 2 are negative 4 and positive 2. Split and solve.
Wait, so you need x squared and x over...
Yeah, you can't combine them.
So you couldn't have just taken out x, right?
No.
Because you have to move the 8 over.
Exactly. You can only do that if it's equal to 0. So as soon as you see an x squared and an x, it should be like your hint. You're going to have to get everything to one side and factor. We already solved this one. I plugged it back in because it's the same one as the one we just did with graphing. So what was it? 4, 5, and negative 2, negative 7. So we already solved, but you would have taken that and plugged that back in. And it doesn't matter which one you plug it back into. You would have gotten the same answer either way. Questions? Yeah. All right, then comes the word problems. So these are like, we've got interest. We have specific ones that are like break even and equilibrium. But then you could get a system one that is interest. You get a system one that was dealing with perimeter. You can get a system that's dealing with something you bought, ticket price. Like all those other things kind of get grouped into one kind. So this one says Eddie invests $5,000 in 2 stocks. Stock A yields a 5% interest. Stock B yields 6%. If he earns $280 in 1 year, how much does he invest in each stock? So if we want to make stock A the X, stock B the Y, what's one relationship we know about them?
That's $5,000.
The total investment is $5,000. So X plus Y equals $5,000.
How did they know it wasn't 280?
Because that's the interest earned. So if you're talking about interest, you have to give it its percent. That's the other relationship, right? Stock A was why did I put the Y there? Sorry, the Y should not be there. That's confusing. The Y is stock B. Stock A is 5%, so 0.05 times X, which is what we made stock A, plus B is 6%, 0.06 Y, equals the interest earned, which is $280. Yep,
So the percent's always equal to interest, right?
correct. And you always going to convert it from percent to decimal when you plug it in. If you want to get rid of it again, like if I want to go back and get rid of these decimals, I can. I'd have to multiply everything here by 100. So I'd get 5x plus 6y equals 2,008 or 28,000 because you got to add on 2 zeros.
You always do the 2 decimal places?
You move them however many is going to get rid of the decimal.
No, I mean before that.
Yes, always. So if it had said 5.5%, let's say, it would have been 0.055x. You'd have to move it 3 zeros. So you'd have to move it times 1,000. To put it in, to plug it in, you move it 2 places left, and it'd be 0.055, right? But if you wanted to get rid of the decimal, you'd have to move it 3 places this time. Yeah.
Would you have to do that since we're getting
No, you don't have to. Yeah. Okay, so now, I don't know about you guys. You could use substitution, but I tend to use elimination with these, okay? You can solve for x or for y in the top and use substitution, or I can multiply everything by a -5. And set up for elimination. So these are going to cancel, and y would equal 3,000. Take this and plug it back in anywhere. It could go up here. I could just say, okay, it's 5,000 minus that, and I'd get 2,000. And then you have to be specific. It would be $2,000 at 5% and $3,000 at 6%. There are going to be times when the numbers are nice and round, and then there are going to be times in which they're not, okay? Which is why I'm giving you the scientific calculator. You cannot freak out here. You're going to get weird decimals. It's fine. We talked about it when we went over these, but there also, this is a scenario in which I give you the total amount invested. But you could also have things like there's twice as much in one account than there is another. Or there's $3,000 more in one account than there is in the other. So you've got to be able to set up that kind of relationship in multiple ways. All right, so those are interest problems. Then came break even. So Ms. Palacios invested $14,000 in equipment to print yearbooks for Archbishop McCarthy High School. Each yearbook costs $7 to print and sells for $35. These are cheap yearbooks. How many yearbooks must she sell to break even? So for break even, we're looking for where revenue equals cost. Sometimes they gave you the revenue and the cost function. Sometimes you had to set it up. So you want to be prepared for both. Revenue is how much money you're making on these, right? So how much are we selling each yearbook for? $35. So it'd be 35 times X. Cost is what you're having to put in money-wise. So how do we break down cost? 14,000, that's how much the initial investment was. Plus 7X, $7 per yearbook. So usually with, say again? 7X. They're both X. So our second variable here is the R and the C. They look like systems, but then we immediately set them equal to each other. Yeah. So the goal here is to set R equal to C. So I do 35X equals 14,000 plus 7X. Subtract the 7X. 28X equals 14,000. Divide both sides by 28. So this time it's a nice even round number. 500 is how many yearbooks you would have to sell in order to break even. But remember with these, we always round up. So if she had to sell 500.1 yearbooks, and you say 500, she has not broken even yet. So these we round up. She would have to sell 501 yearbooks in order to break even. Yep. So on break even, my answer is always a whole number because you can't sell 0.1 of a yearbook. And we always round up because if you round down, you haven't broken even yet. You're still losing money. So you want to round up. So if it had said 500.2, I'd still round it up to 501. Yeah, sure. Questions on break even? So break even, set up a cost, set up the revenue, set them equal to each other, round up.
Are we gonna have one of each of these?
No.
For the revenue, the cost, it's always the investment plus how much you're selling.
Right. Yep.
The cost is how the amount.
The cost is how much you're paying to an overall setup, and then like the whatever it costs to produce each one, and revenue is how much you're selling them for. Yep. All right, equilibrium point. So those two were really in 7.1 and equilibrium was in 7.2, but all the word problems were to get looped together, so I just put them together. The equilibrium point has two parts, okay? You're talking demand and supply. These, they will give you the demand and the supply. And the goal here is to find the price per unit and the number of units. So you need both X and you need P for these answers. So it gives you literally demand is P equals 65 minus 0.05X. Supply is 0.5X minus 45. It's already giving you the system. You just have to solve it. So here's the mistake you can't make with these, and people do it all the time. You see a decimal, you want to get rid of it. So on the one on the left, we would have to multiply by what? 100. It would be 100P equals 6,500 minus 5X. The one on the right, you'd have to multiply by what? 10. 10P equals 5X minus 450. Can you now just set these equal to each other? No, because one's 100P and one's 10P. So in my opinion, is just set it up. You have a calculator. Just set it up from the beginning. Then you can move your decimal if you need to, but you also have a calculator. I wouldn't even waste the time. So I would not, like it's in your nature to freak out when you see a decimal and want to get rid of it as soon as you can, but these make more sense to just set this equal to this because they're both equal to P. So 65 minus 0.05X equals 0.5X minus 45. And then solve, but use your calculator.
What would have been the problem with doing what you said?
Because one is 100P and one is 10P, so you can't substitute them in.
I thought as long as they were equal to they were
Right, it wasn't the individual equations that were wrong. The individual equations are right. Setting them equal to each other would have been wrong.
You couldn't have put
One had 100P and one had 10P. You could stack them and do elimination.
that's
Yeah, you just have to change them again. I think it's way more complicated. I would do it this way. So add the 0.05X. 65 equals 0.55X minus 45. Add the 45. 110 equals 0.55X. Divide both sides by 0.55. X is 200. This has to be a whole number when you answer it because you're finding a specific amount. So there is no rounding if you do it correctly on equilibrium. Equilibrium should produce a nice whole number because it's a number of units you need to sell. So I need to sell 200 units. Yep.
You also just set these both equal to 100 as, like, when you make them equal to each other.
You would have to move both. So like if you did, okay, now I also need the price per unit. So I could plug them back in either place. I could plug it back in here or here because they're going to give me the same answer. P equals, I'm going to grab the second one, 0.5 times 200 minus 45. And I get P equals 100 minus 45. P equals 55. So my answer would be 200 units at $55 per unit. You need both parts with equilibrium. The directions will say it. Find the number of units and the price per unit. But I'm going to skip to the partial because we haven't physically done that together yet. So the first from 7.3 is your multivariable, right? This is the one where we want to label them as 1, 2, 3. We want to pick 2, cancel out a variable. That's our new one. Then we pick a third one, whichever one we didn't use that first time, with either of the other two, cancel out the same variable, use elimination to break it down to 1, take 1, plug it back into the one with 2 equations, one of the new ones, and then take that, plug it back into initial one. So I will come back on the video and I will work through an example of this, but what I'd like to do is get to partial fractions. Okay, remember there's 2 kinds of partial fractions. The one that has the repeated factor, that's your bonus, that was like the warm-up, and then one that's not repeated, so something like this that counts as a regular question. So for these, you want to look at the bottom and see if it can be factored, which we can factor this x plus 1 and x minus 1. It's not a repeated factor because those are different terms. Then there's two denominators there, or 2 factors there, so I get a over x plus 1 and b over x plus 2. Order there doesn't matter. I mean x minus 1. Jeez Louise. Now I want to compare the second denominators to the first. So what's missing from here to here? X minus 1 for the A, x plus 1 for the B. Now I look at just the numerators. 3x plus 5 equals A, x minus 1 plus B, x plus 1. Now I want to cross these out one at a time. So I can either look and say, what would I have to plug in to get rid of A? Look, what would I have to plug in to get rid of B? Or I can come back up to my factor denominator, set them each equal to 0, and get the same numbers. So x equals 1 and negative 1. Then, one at a time, I'm plugging that in. Negative 1, positive 1. Every x becomes a negative 1. Negative 3 plus 5, that's 2, equals A times negative 2. Here's my 0, so the B's gone, which was the whole point of that. And A is negative 1. Repeat that whole process with positive 1. 3 times 1 plus 5 equals A, 1 minus 1, B, 1 plus 1. 8 equals, this time the A has the 0, so it's gone. B times 2, divide both sides by 2, and B is 4. Yep. It's okay, because your A should be over your x minus 1, right? Yeah. Order doesn't matter as long as the right one goes over the right, like the one it's supposed to. Yep. So A here was negative 1 over x plus 1, and B is 4 over x minus 1. So a couple of things about format there is if it's a minus, remember to pull it in front. And if it's a fraction within a fraction, you can't leave it in the top. Remember to take the denominator and pull it down to the bottom. So let's just say I got like A was 2/3. I can't leave it as 2/3 over x plus 1. I have to take the 3 and pull it to the bottom. So it'd be 2 over 3 x plus 1 like that. Okay, you can't leave a fraction within a fraction. You got to pull the denominator down. So 3 variables, 3 equations, right? And I think I counted this as a double question. You're going to, I'm going to number them just so that we can talk about it. But you want to look at the 3, right? And the goal for the first round is to pick 2 and cancel out 1 variable. But then you have to use the third to cancel out the same variable. So try to plan a little bit ahead. Which, I just kind of look down the rows, or the columns, right? Like, what's the easiest to cancel out? I look at that way. So what do we think is the easiest to cancel out? Y. Why would you, actually x, not that big of a deal. I would not use z here, right? Because I can pick these 2 together, but then I have to pick something with 5. Ew, right? So that's why I would just make sure you kind of try to get a step ahead of yourself. So if we're going to do y, what 2 do you want to grab first? 1 and 3. So negative 6x plus 5y plus 2z equals negative 11. And then 4x minus 5y plus 5z equals negative 4. Be so very careful. You don't want to make a silly mistake along the way and have to redo this. This is new 1. Now I didn't use 2, so I have to use 2. Which one do you want to compare or pair it with? Why 3? Good. So I would have done the same. 3 already has a negative, and I don't have to worry about changing the signs. And then I just have to multiply 2 by 5. Don't forget to go all the way to the other side of the equal sign. Negative 6x, these cancel, plus 25y, or 25z, sorry, equals negative 49. That's new 2. Okay, now I have to match up new 1 and new 2. I need to cancel something out, so obviously I don't want to do the z's. I'm going to multiply the top by a negative 3. These cancel. Positive 4z equals negative 4. So z equals negative 1. There's the first of the 3. I take that and I have to plug it back in where? One of the new ones. Doesn't matter which one, but you definitely have to do one of the new ones. So this one might be a little bit easier. Negative 2x plus 7 times negative 1 equals negative 15. Add the 7. Divide by negative 2. X is 4. And then I have to plug them back into one of the original ones. Again, it doesn't matter which one. I'm going to take the one with the least amount of coefficients. 2 times 4, negative 2 times 4, plus y plus 4 times negative 1 equals negative 9. And y is positive 3. So 4, 3, negative 1 is your solution. Yep. Sure. So 1, go slow to go fast with this. Be careful. Watch your signs. 2, if you get stuck and you have to restart it, make sure you finish the partial fractions before you go back and have to completely restart it. Watch your time. 3, if you get a really crazy fraction, I didn't do that to you. You messed up somewhere along the way, okay? A half maybe, but 782 over 17, not something I'm going to put on there. So just be really careful. And if you have the solutions for the extra practice from Friday, this is the solutions for the extra practice from Friday. So 1 should have been negative 5, 3. 2, negative 4, 0, negative 2. 3 was negative 4 over x minus 1 over x minus 1. And again, that order can be switched. 4, negative 2 over x plus 4 plus 5 over x plus 5. And again, that order can be switched. If it is switched, the 2, the negative's got to be in between them. No. Hang on. I'm sorry, 7 was such a pain. Like if in the beginning of the day, they didn't even bother. They like tried and just wrote can't do it. But it is factorable. It's nonsense to get there. It is factorable. If you're bored and at home and wondering how to do it, it's there. Yeah, super fun. Miraculously, by the end of the day, people started to figure it out, aka Google told them how to do it, okay? I will not do a non-factorable denominator, but there will be a repeated factor, so make sure you know how to do these, okay? This is like that bonus one. 7 would be the repeated factor one, so that's like the bonus question. 6. And then 7, and that's, I apologize. I did work it out. It is here. It's just, most of you, if you got the factored part of it, you were golden from there on. It did factor weird because it was, I saw factor by grouping and I was like, sweet, we haven't practiced that in a while. I didn't realize it doesn't truly, like you have to factor, you have to group it in a very different way. You had to like break apart the 7x squared and you had to break apart the 11x and then you could group it in 3s. And from each of them, the greatest common factor was x minus 1. But that is not going to happen on your quiz, so don't stress too much about it. The process after that is what's important, but the original factoring, I would say, don't stress about.